given. So internal energy equation is 3 by 2 Ni into T. So N is a number of molecules, I is a gas constant, and the T is a absolute temperature. Now I will talk about the molar specificity at the constant volume. Molar specificity at constant volume. So when we are providing the heat to the gas, the temperature will be increased. The rate of change of the temperature, when we provide the heat to the gas, so the temperature will be increased. So the amount of the heat absorbed by the gas and the temperature change calculated by the equation. So this is the initial state, the initial state of the gas is heated to final state. So that in this case, to the change, the heat is equal to Q. So Q can be calculated and CV into delta T. So and this is the number of the molecule, say the corresponding value, and delta T with the change of the temperature. So in the meantime, we can also change the internal energy change. So the change in internal energy. This means that when you provide the heat to the gas, so their internal energy will be changing. So internal energy change can be calculated by the equation. So the change in the internal energy. This is equal to the delta EIND. The change in internal energy is equal to NCV into delta T minus W. So this is the equation. If you read that this is the work term. Work term, the produced by the gas. So this is the work term. So if the work term is 0, in this case, EIND is equal to NCV into delta T. And therefore, if the W is equal to 0, delta EIND is equal to NCV into delta T. So that we can calculate the CV is equal to delta EIND divided by N into delta T. So this is the equation we can calculate. So calorific value will be that we can calculate by CV equal to the delta EIND divided by N into delta T. And also there's a change in the entropy. Entropy is the rate of change of the heat. So there is a change in entropy. So change in entropy is delta S is a final state and the initial state, and it's equal to the integration initial to final state dQ by T. So this is for change of the heat. Change in the entropy can be calculated. So the integrations are between the final initial state to final state, and rate of change of the heat divided by temperature. So this is for the change in the entropy. The change in the entropy calculated. So therefore, the change in entropy means the positive change and the negative change. When we take in the heat again, we need the positive change, and heat is taken out from the gas with the negative change. So this is why the heat losses and the heat gain can be indicated by the positive and the negative change. So this is become the heat losses. So in this case, delta S gas is equal to negative Q by T, and heat gain. So delta S gas can be calculated positive Q by T. So this is for the change of the heat. In the meantime, also we can provide the force. So when the internal heat is changing, it can also produce the water and the force. So in the meantime, any gas, we apply any force in internal water, gas internal energy will also be changing. So therefore, the force due to the entropy can be calculated. Force due to entropies. So this is that dE is equal to dQ minus dW. So this is the change of the heat minus the difference between the change of the work done. So this will use the change of the entropy can be calculated. So those are the equations to calculate the change of the heat. Okay, now the change of the heat and the change of the entropy, we can produce a gas engine. Gas engine means that we run a gas engine here. So this is for the Stirling engine. STIRLING engine. So engine operation principles are we can draw as a pressure and the volume. So this is the gas pressure. Particle acid, horizontal acid is the gas volume. So gas volume is the initial volume with just ABCD point. This is A point. When the gas will be expand, so pressure reduce the gas will expand, so this is the volume will be bigger. So this is this reach the B point. Okay, so this reach the B point. After that, when you change the draw the temperature, so the pressure will be going down. And after that, we increase the time it produces the heat. After that, temperature is get operated, so the pressure will increase, the volume will be smaller, and then we go back with the pressure higher, so we reach the initial state. So this means that this for saturation, here is we provide the Q. We provide the heat here. So in this case, this will when you provide heat, pressure will increase, and then we produce the heat, so that this will be when the pressure is going down and volume will be expand, and then so this one here will dissipate the heat, and here is also the dissipate the heat. So this is the heat absorption point, this is the heat dissipation point. So engine will be working like this. Engine will be working like this. Firstly, that when the engine working, we have to press the gas. By pressing the gas, in this case the volume will be decreased, and pressure will increase. And then you increase it, you provide the heat, so the pressure will increase, and then the gas will be the flow, and their pressure will be going down, and volume will be expand. And here is the dicer there that we dissipate the heat, so that the pressure will be going down. So this will be working like this. This engine circuit. Absorb the heat, the temperature, pressure will be higher between this portion, and so the heat and pressure will be higher. And then here is the expansion, and then the volume will be bigger, and dissipate the heat, so pressure will be going down. And this state, we compressing. By compressing, the heat will be coming out. So those targets working with the engine. So this engine working procedure. Engine working procedure means the engine will compress and provide the heat, so expand and expansion and dissipate the heat. So this target will be going after one target to another target. So this is the gas engine operations procedure. Because petrol engine, they are operation principle. So this is the Carnot cycle. So from the C to D compress the gas. So volume is a decrease from the VV to the VA, so will be decrease. So the E QL will be dissipated. And then here is heating the gas. Heating the gas means that in the engine we ignite the engine, the carburetor. Carburetor is you combine the air and the petrol, they combine and mixture to throw into the engine cylinder. And for the petrol engine, we ignite this mixture of the air and the petrol by the electric coil. Electric coil means the expand. So this is provide the heat. This is for the petrol engine. For the diesel engine, all the air is compressed. When the air is very compressed, so in the front and north, diesel is free. So the explosion and we walk in. So this is for the petrol engine. Firstly, compress. Then compress the gas, and here we provide the heat. Provide the heat means that this is the ignition coil. Ignition coil providing the heat. So that this ignition coil is, so this is the pressure we use the constant expansion. Expansion happens so the volume go from the A to B, so volume expansion. And in the middle is also taking the additional heat, and here is cooling down. cooling down means C to B to C cooling down, so heat will be dissipated. So that function is over and over again. So this is for the Stalin engines operations cycle. So in the cycle, you can see that the jets are pressure, higher, lower, volume, expansion, contraction, and the temperature will be cooling out and cooling down. So they working on this cycle. Where the engine here, so this is for the engines are efficiency can be calculated. Efficiency. 1 minus low temperature divided by high temperature. So this is the efficiency. So first engine is at 400 and 500. Low is 400, is at high 500. So A, we calculate 1 minus 400 by 500. So 1 minus 0.8. So you got a 0.2. 20%. And a B is a 1 minus 600 by 800. So this is for the 1 minus 0.75. So this is for the 1 minus 0.25 or the 25%. And a C 1 minus 400 by 600. So this is a 1 minus 0.66. So 1 minus 0.66, so we call it 0.34. So 34%. So you can see that the CSS are 34%, B is at 25%, A is at 20%. So that we can read greater is a C. C, then B and the A. So this is the we can write the engine like this. So this is the we can calculate. So in this case, our Carnot engine operates between the temperature. The high temperature is 850 degree Kelvin and the low temperature is 300 Kelvin. So we have to calculate the efficiency. So efficiency can be calculated. The formula is E equal to 1 minus TL by TH. So the 1 minus low temperature is a 300 Kelvin. High temperature is a 850 Kelvin. So my solving this was 0.347 for 35%. So the operations efficiency is of the engine will be 35%. And this is what is the average power beyond the engine. So in this case, this temperature change is because the temperature change also is water what is done, the 1200 joule of the work has been done. So the power can be calculated. Power is water divided by time. So this is the power. Power is equal to W by T. The water is we already calculated the 1200 joule times the 0.25. So by 1200 divided by 0.25, you got the 4800 watt or 4.8 kilowatt. So this is for the power can be calculated. And see how much energy QA is HF as a heat from the heat temperature, the server, every cycle. So we have to calculate the heat. So the heat expression is you can calculate the QA. The formula is equal to the water divided by efficiency. Water by efficiency, so the output water is 4.8 kilowatt and the efficiency is 65%. So the input is heat energy and heat energy is transferred to the mechanical energy by the engine. And therefore the efficiency already given, so the output mechanical energy divided by efficiency, so you can get the input of heat energy. So therefore the output mechanical energy is 1200 joules. Mechanical power 1200 joule and efficiency is 0.647. So you got the 1855 joule. So this is for the heat HF is 1855 joule. And the D. How much energy QF deliver as a heat to the low temperature server every cycle. So in this case we can calculate for the QL. QL formula is QA multiply W, the equation. So QA is we call it 1855 and W in joule is 1200. So you got the thing 355 joule. And the E. The E is by how much gases entropy of the working substance change as a result of the energy transfer to it from the high temperature reservoir from it to the low temperature reservoir. So the high temperature reservoir entropy can be calculated. Delta SA. Delta SA equation is QH by DH. So QA we already calculate QA is 1855 joule. High temperature T is 850 K. So 1855 like Kelvin, so that you got that 2.18 joule per Kelvin. In the mid-ice load and temperature entropy. SF formula also the QF by TL. The QF by TL is QA is we already calculate. This is for the QA calculation this is for negative transfer. Load temperature transfer is negative transfer. So this is a negative transfer. Therefore, we put a negative, QA is 655, and CA is 300. So therefore, you got the minus 2.18 joule per Kelvin. So this is for us. In this case, net temperature change. Delta S is equal to the delta SA plus delta SS. So that will be 2.18 plus minus 2.18. So that will be 0. So no temperature, net entropy change in the system program. System programs are whether is it possible or not. So we have to assess. So the engine has the efficiency 75%. So this is engine 75% operated within the boiling and freezing point of the water. So that whether possible or not. So we have to calculate the theoretical calculation of the efficiency. And here the E is equal to 1 minus TL by TH. So 1 minus the low temperature is a freezing point. Freezing point is 0 degree, boiling point is 100 degrees centigrade. So 0 degree centigrade means 0 plus 2 centigrade. 0 is a degree centigrade. So we change to the Kelvin to plus a 2 centigrade. 100 degrees centigrade. 100 is a degree centigrade. So to change to Kelvin plus a 2 centigrade. So the 0 plus 2 centigrade divided by 100 plus 2 centigrade. That will be 1 minus 2 centigrade divided by 3 centigrade. So this engine will be 0.268. So around 27%. So therefore the E is impossible. So we can assess the operation of the engine by this formula. Okay, last week this is for the harmonic motion and the weight. Especially that we see the spring here. This is a spring. So we pull the spring, so spring will elongate it. So this is the length with the delta I change. So initial L, so initial length is when you pull, so then we will change the delta S. Okay, so when you release the force and release, so springs will release the contract. So this will be the spring motion will be the expand contract like this. So this motion will be the harmonic motion. Firstly, the spring, you pull the spring will elongate it, and when you if the total length will be greater than the longer than the original length, when you release the force, so the total length will temporarily shorter than the original length, and then we expand again. Expand and the contract happen like this. This is we call the harmonic motion. So this harmonic motion we can calculate the angular velocity can be calculated. The velocity is angular velocity. Omega can be calculated square root of K by M. So in this case, K is a mass, M is a mass, and the K is a constant, spring constant. So K equal to spring constant. M is a mass. So the angular velocity omega can be calculated square root of K by M. So this is for the K, the spring constant, and the M is a mass. And also that our frequency can also be calculated as frequency. Frequency S is omega by 2 pi. So the omega can be calculated square root of K by N. Frequency S is equal to the omega by 2 pi, and the period T. So T is equal to 1 by F. So this is a formula to calculate for the door strain. This is for the block to the mass is 380 grams. And also the stepping cosec K is 65 Newton per meter. So we have to calculate the angular velocity. So angular velocity omega is equal to square root of K by M. So square root of K is 65 divided by the 0.68. So by solving this one, you got the 9.78 radian per second. Also, we can also calculate the frequency F. Frequency can be calculated omega divided by 2 pi. So omega is 9.78 radian per second. 2 pi is 3.1416. So by solving this one, frequency wave is 1 by 6 half. And then the period T can be calculated. The period T is equal to 1 by F. So 1 by 6, so the period wave is 0.64 seconds or 0.640 milliseconds. So then we can calculate. And then we also calculate for the amplitude of the oscillation. So the amplitude of the oscillation is the distance h is 11 centimeter is the moving. So therefore the amplitude of oscillation is h and is 11 centimeter. So B h and is equal to 11 centimeter. And the speed. We also need to calculate the maximum speed. Maximum speed. So the maximum speed of Vn can be calculated. The formula is omega multiplies Hn. So this is the maximum speed. So Vn is the maximum speed, and the amplitude of the oscillation is 11 centimeter. Angular velocity is 9.78 radian per second. So the maximum speed Vn can be calculated. Omega multiplies Hn. So omega is equal to 9.78 radian per second. H is 11 centimeter. So by solving this one you got the base 1.1 meter per second. And a D. And also what is the magnitude AN of the maximum acceleration of the block? So maximum acceleration block can be calculated. AM is equal to omega square multiplied Hn. The equation for the AM. AM is equal to omega square into Hn. The omega square is 9.78 square. Multiply Hn is equal to 11 centimeter, so 0.11 meter per. So 11 centimeter, 11 divided by 100. So this is also 11 divided by 100. So therefore this one will be AM is equal to 11 meter per second square. So this is answer for D. And E, what is the phase constant of the motion? Phase constant of motion means at the time 0, the block is equal to H equal to Hn. So therefore at the time 0, at time t equal to 0, H equal to Hn. And therefore in this case H equal to Hn, so the cos phi is equal to H divided by Hn. So the cos phi can be calculated. H is equal to H and Hn are the same. So there's a cancel. So the cos phi equal to 1. The phi equal to 0 degree. So phase difference will be there. 0 degree we can calculate. And another one will be phase total can be calculated. HC. The F. HC means oscillation. The oscillation function you have to write down the equation. The function is Hn multiply cos omega m t plus phi. So that's the equation. So omega t plus phi. So then Hn is equal to 0.11 meter multiply cos omega is 9.78 t plus phi. So this equation is 0.11 cos. So phi is 0. 9.78 t plus 0. So then 0.11 cos 9.78 t. So this is the HT. The oscillation function can be mathematically written the equation. So this is a 0.11 cos 9.78 t. So as a displacement of A0, the block is the as a chi 0, the displacement A0 is minus 8.5 centimeter. And when the velocity V0 is minus 0.92 meter per second, and acceleration A0 is 47 meter per second squared. So those are given in the formula. So therefore, we can calculate the equation here. A0 is equal to hn cos phi. Similarly, the V0 can be calculated as minus omega hn psi phi, and the A0 is equal to minus omega square hn cos phi. So those are equations to calculate for the weight moment. And therefore, the omega can be calculated. If you know the A0 and A0, the omega can be calculated. A0 is hn cos phi, A0 is the omega square hn cos phi. So that we define the equation, the equation 1, equation 2, and equation 3. So we can write down the equation here. Equation 1 is divided by equation 3. So the 1 divided by 3. So A0 by A0 is equal to hn cos phi divided by omega square hn cos phi. So now we got the thing is what you got the thing is A0 by A0. So cos phi can be cancelled. Hn cancelled. So this is a 1 by omega square. So the omega square can be calculated. So then we get so this equation is A0 is minus omega, so this is a minus. So omega square is equal to A0 by A0. Minus A0 by 0. Omega is equal to square root of minus A0 by A0. So we substitute A0 by magnitude. A0 magnitude is already given 47 meter per second square, 47. A0 magnitude minus 8.5. So divided by minus 8.5. So by solving this one, we got the thing is 23.5 radian per second. So angular velocity, we can calculate by this way. So this is for the answer for the T. And the P, what is the phase angle? Phase angle also needs to be calculated. So in this case, to get the phase angle, we have the ratio of the V0 and A0. So equation 1 is A0 is equal to the hn cos phi, V0 is minus W hn psi phi. So that we equation 2 divided by equation 1. So equation 2 divided by equation 1. Equation 2 is the V0. Equation 1 is the A0. So equation 2 is the minus W hn psi phi divided by equation 1 is the hn cos phi. So then we have V0 by A0 we can calculate. So this is the V0 divided by A0 minus W. So this is the minus W. In the end, I can say psi phi and cos phi is the tangent phi. So the tangent phi can be calculated. So minus V0 by A0 omega into A0. So minus V0 is we got calculate. V0 is minus 0.92. Minus 0.92 minus omega. So W can be calculated. So W is at 23.5. And A0, so A0 we calculated. So original H is 0 is equal to the minus 8.5. So by solving this one, you got a 0.461. So 0.461 we can calculate, and that is phi is equal to minus 25 degree or 155 degree. And then you can calculate hn. Hn is equal to the A0 by cos phi. So cos phi can be calculated. So in this case, phi is equal to minus 25. So you got to say that hn is equal to A0 is minus 0.085 meter divided by cos minus 25. So therefore, the minus 0.094 meter. And also that the phi is 1.5. So hn can be calculated. So this is a minus 0.085 divided by cos 155. So this is so hn can be calculated. So this will be 0.094 meter or the 9.4 centimeter. So those are the answer for this question. So this is for the answer for question B. spring is moving, small is spring moving, so the spring carry the energy. So energy in this simple harmonic motion can be calculated. The energy is a UT is equal to the half into KA square. Also can be also calculated half into K 8m square and then 4 square omega t plus 5. So this is about the energy and the simple harmonic motion can be calculated. This simple harmonic motion can be also be calculated. The equation the formula for the simple harmonic motion is m into dA squared by dt squared plus b into dh by dt plus k8 equal to 0. So this is the equation for the simple harmonic motion. So therefore any moments can be calculated. So any elongation can be calculated. Any the formula is hn equal to e power minus bd by 2n, and the cos omega z plus 5. So in this case, omega z is motions of frequency. So this formula is equal to the square root of k by n minus b squared divided by 4n squared. So this is for the simple harmonic motion. So the mathematical formula is mass is m d squared by dt squared. So the rate of change of the displacement, b is a constant, h by dt is the rate of change of the moment, and the k8, k is a spring constant, h is about the elongation distance, elongation length. So the h is so any size the length of the spring can be calculated by this equation. Hn equals multiply e power minus bd by 2n. Cos into omega z plus 5. So omega z is the motions are radian frequency, radian velocity. So radian velocity omega z is equal to square root of k by n minus b squared by 4n squared. So this is the equation for the simple harmonic motion. The simple harmonic motion velocity and the displacement can be calculated by the equation. We can use that something here. This is a sub-bridges book. So we use a spring. So this spring is this is a mass m. So this mass is inside we utilize a liquid. So this is a liquid. So this is a spring moving. So this mass is another liquid. So because the liquids we are making the damping. Damping means movement is a control, not too fast. Because the moment the damping liquids are controlled, moments are not to be too fast. So this is for the damped simple harmonic motion. Without this liquid, the moment is free, undamped motion. So undamped motion we have already calculated with the other formula, but the damped motion we have to use the Doe formula. So this is for the especially all the mass is put into the spring. So hydraulic liquid they are moving. So those moments in the hydraulic liquids follow the damped simple harmonic motion. Oscillation. Oscillation is when the waveform is moving here. The waveform frequency firstly we like it. Frequency gradually going down and going like this. So this is for the subject which follow this graph. So this is for the equation. So this equation means that this top equation is equal to hn e power minus bd by 2n. And this bottom will be hn e power minus bd by the 2n. So this equation this is minus hn e power minus bd by 2n. So we get hn e power minus bd by 2n. So this is oscillation. Oscillation means that something is moving fast, and after this moving gradually going down and finally stop it. So in this case, this brings moving with the oscillation function also possess energy. Energy ED can be calculated half into k into a square, hn square, e power minus bd by m. So this is the equation. So b is a constant, k is a spring constant, and the hn is a maximum motion, and t is a time, m is a mass. So this is for the damped oscillation. The energy is related by the damped oscillation body can be calculated by that equation. This is for the damped harmonic motion system. So we have to calculate. So the mass is at 250 grams, K is 85 Newton per meter, and the B constant is 70 gram per second. And also the G by second, so what is the period of motion? The period of motion can be calculated. Period of motion T is equal to 2 pi square root of m by K. So we substitute here 2 pi. Mass is 250 grams, so 0.25 kilogram. Divided K is 85 Newton per meter. So this one we calculate, so that will be 0.34 seconds. So this is for the A. And the B, how long does it take for the amplitude to reach the half of the initial value? So this is because we can calculate. The formula is HT. HT is we use that formula here. HM is we multiply E power minus B divided 2M. So E power minus B divided 2M. HM E power minus B divided 2M. So HT is half of the amplitude. Half the amplitude is half H2. Half of the HM is equal to HM E power minus B divided 2M. So we have to calculate the size. Size of the both sides that you can take this log. So that this is the element. This is 0.5. It's equal to E power minus B divided 2M. So the and 0.5. So minus B divided 2M. So size can be calculated. T is equal to 2M and 0.5 minus B divided minus B. So the 2M substitute, the mass is equal to this 0.25 kilogram and 0.5 divided B. B is 70, so 0.070 kilogram per second. So by calculation, T will be 5 seconds. So therefore, we calculate that T is equal to 5 seconds. This is the answer for the T. And the C is how long does it take for the mechanical energy draw to 1/2 of its energy value. So in this case, we can write down the energy here. Half of the energy value half into K Hn square E power minus PD by N. So this is what the kinetic energy value. So this kinetic energy value, we have to find the half of the value. So half of the initial value half into K into half K into the Hn square. So this is for the kinetic energy. Kinetic energy equation is this one. Half the initial value is multiplied with half. So this equation we have to find out the T. So T also can calculate. So here we calculate is E power minus PD by N is equal to the 0.5. So minus PD by M is equal to Ln 0.5. So T can calculate minus Ln 0.5 multiplied with the M divided by B. So the minus Ln 0.5. So mass is already calculated. Mass is 0.25. Divided by B is 0.70. So by solving this one, what you call the spin rate, that will be 2.5 seconds. So those are the answers of this problem. There will be the time of the wave, mechanical wave, electromagnetic wave, and the metal wave. So that is the type of wave. Mechanical wave. Mechanical wave, electromagnetic wave. And the metal wave. So mechanical waves are the waves happening in the spring. So those spring waves are the mechanical wave. Electromagnetic waves, electric fields are generated electromagnetic waves. Metal waves are water waves. Those are the metal waves. So those waveforms can be utilized. So when the waveform waves are only this waveform, this is we call the path. But the waveform rotation with the side wave, this is we call the sinusoidal wave. So path and the sinusoidal waves will be right going now. So in this case, the sinusoidal waves is you can see that the movement is up and down movement. In the middle, wave going to this direction. When the wave follows it out, the forward direction, all the metals are they are moving up and down. So therefore, the wave can be the two ways, transverse wave and longitudinal wave. So this is a longitudinal wave. Longitudinal wave. This wave is a transverse wave. So horizontal movement is a transverse wave, and up and down movement is a longitudinal wave. So this is a kind of the waveform we can write down. So the way of the velocity can also be calculated. So depth of the wave and the way of the velocity. So in this case, we can write down the equation. So waves are h into t. So this is for the equation. So this is for y-axis position. When there's a h moving at the wave moving at the h distance for the time t. So that also the y position. So y distance. How much y distance can be calculated? So this is y bracket h means the h is moving for the h distance horizontally for the time t. So that there will be the y position can be happen. So this is the h movement. So this is the y position at the time t. So this one can be calculated by formula ym sine ka minus omega t. So this is for the equation to calculate the y position of the wave, y position of the particle for the wave traveling for the h distance horizontally at the time t. So this is a y and it can be multiply with kh minus omega t. So this equation for the wave position can be calculated. In the meantime, we can also calculate the wavelength and the phase, amplitude of the wave. So this is the amplitude of the wave. This one, this is the amplitude of the wave. Amplitude. So one wave is going to this distance. So this is the wavelength. The wavelength and the amplitude of the wave can be calculated, represented by this equation. And therefore, we can also calculate. So angular wave number can be calculated k. So this is k is the angular wave number. Angular wave number is equal to 2 pi divided by lambda. So lambda is the wavelength. Lambda is the wavelength, so the 2 pi divided by lambda, so you can calculate the angular wave number. In the meantime, we can also calculate for the angular frequency. Angular frequency. So angular frequency can be calculated as the formula is omega equal to 2 pi by t. And the frequency. So frequency f is equal to the 1 by t. So this is the omega by 2 pi. So those are the equation for the wave equation. So we can write down the formula. So in this case, the amplitude of the wave. So this is the maximum to minimum distance. So this is the one length of the wave, the wavelength. So angular wave number is equal to the 2 pi by lambda. Angular frequency omega is equal to 2 pi by t. And frequency is f equal to 1 by t. In this case, f the frequency, t is the period, and lambda is the wavelength. So lambda is wavelength. T is the period. Period is the time required to travel the one way. So this is one way here. This is time required to travel. So this is the y. So this becomes a t. T is the period. So number of how many waves per second wave is our frequency. In this case, the f is equal to 1 by the t. Speed of the traveling wave. So in this case, the speed of the traveling wave also be calculated by formula. The speed of the traveling wave. So the equation is Ka minus omega t equal to constant. So equation for the speed of the traveling wave can be calculated. So kh minus omega t is equal to the constant. And therefore, we write down the equation. The velocity v is equal to omega by k is equal to the lambda by t is equal to the lambda by frequency. So v is a linear velocity. With the linear velocity, k is a wave constant, and lambda is a wavelength, and f is a frequency, t is a period time. So we can write down the equations the speed of the traveling wave equal to v is equal to omega by k equal to the lambda by t or the lambda multiplied by f. Okay, so this equation already given here. Y8t is equal to the 0.000327 psi 72.1 t minus 2.72 t. So in this case, we have to calculate the amplitude of the wave. So amplitude of the wave is here 0.000327 meter. So Hm is equal to 0.00327 meter or 3.27 millimeter. So multiply with 1,000. So this meter multiply with 1,000. So you got the 3.72 millimeter. Here, what are the wavelength, period, and frequency of the wave? So we have to calculate the wavelength, period, and the frequency. So in this case, we made a comparison with the equation. So that we compare with the equation. The equation is Ym sin h minus wd. So this equation, we write down the equation that y8t is equal to 0.00327 psi 72.18 minus 2.72 t. This one will be made the comparison. Y8t is equal to Yn sin kx minus omega t. So make the comparison, you can see Yn is 0.00327, k is equal to 72.1 radian per meter. In the meantime, omega. Omega also can be calculated. Omega is equal to 2.72 radian per second. So we can calculate k and the omega. After that, you can calculate for this wavelength, lambda. The wavelength lambda can be calculated. Lambda is equal to this wavelength, and so lambda is equal to the formula is 2 pi by k. Lambda is 2 pi by k. So the k is the angular wave number. So the lambda can be calculated. Via is the k is equal to the 2 pi by lambda. So the lambda is equal to 2 pi by k. So the 2 pi, 2 is 3.1416. K we calculate is 22.1. So therefore the lambda wave is 0.0871 meter or 8.71 centimeter. So this one multiply with 100. So 8.71 centimeter we got. So this is for the thing. And also the period t can also be calculated. 2 pi by omega. So 2 pi is 3.1416. So omega is 2.72. So that we calculate it 2.31 seconds. And also there's frequency t can also be calculated. Frequency f is 1 by t. So 1 by t, so 1 divided by 2.31. So that's 0.433 half. So this is for the answer for the B. And also the C. C is what is the velocity of the wave? Velocity of wave V is equal to omega by k. So we calculate V equal to omega by k. So omega is, we already know, omega is 2.72 radian per second. And the k is 72.1 radian per meter. So in this case, the formula will be the radian per second divided by radian per meter. So answer is in a meter unit. So the 0.0377 meter per second. So this is the answer we got for the answer for C. And also the answer for the D. Here the what is the amplitude of displacement y at the h is 22.5 and the t is 18.9 seconds. So that we write down the equation here. The equation is given at 0.00327 psi 72.18 minus 2.72 t. So y is equal to 0.00327 psi 72.18 minus 2.72 t. Okay, these are now substitute. So that y can be calculated. Y is equal to 0.00327 psi 72.1. H value is given at 22.5 centimeter, so 0.225. 0.225 meter, so or the 22.5 divided by 100. Minus 2.72. The psi also given at 18.9. So by solving this one, our y can be calculated. There will be 0.00192 meter or 1.92 millimeter. So this is an answer for the problem. So this is for the harmonic motion and the weight.